Alright, number 2 on the final review. So we are talking about a car on a level curve. So when we talked about level curves before in class, there was something that always happened, and that was that the force in is equal to the force out. So anytime you have a level curve, you have something pulling inward, and that's equal to the something pulling outward. That's how you stay on the road. So the inward force is usually the centripetal force in this case, while the outward force is going to be the force of friction. So that is always the case when we do level curves. Centripetal is equal to friction. So while you're doing that, we use the formula for centripetal force and set that equal to the formula for force of friction. So the centripetal force formula of mv squared over r is equal to coefficient times force normal. When you're on a flat surface, you have your object, and the normal force is going to be equal to the force of gravity. The normal force is just the force coming from the surface to support it, and that's going to be the weight of the object. So on a flat surface, you end up with normal equal to gravity, and the force of gravity is mg. So you end up with mv squared over r is equal to coefficient multiplied by mass times gravity. Both sides of the equation have a mass, so you can get rid of it, meaning that you end up with v squared over r equal to coefficient times g. Because the masses are the same, they technically don't have any effect on the problem. So we end up with a formula for the coefficient of v squared divided by rg. We know that from the problem that we have the mass of the car, which we don't need. We know the radius is 20 meters. We know the speed is 10. We want to find the friction, so we have all the information that we need to end up getting our formula and our final answer of 0.5. Right, so that is our coefficient on the surface. Now in terms of a free body diagram, you end up with an object, and that object is going to have a force that's going in, which is going to be your centripetal, and a force that's going out, which is going to be your friction. Those two forces have to cancel each other out in order for the system to be in equilibrium.